G21. Imagine a company being attacked every single second through login attempts, suspicious IP requests, and hidden cyber intrusion. But the security team notices it only after the damage is done. This is the problem we wanted to solve. So, today we are presenting Cybershield, an AI powered real time threat detection platform. Cybershield is a cloud native cybersecurity system that automatically detects threats from system logs, analyzes them using AI, and visualizes everything in real time through a centralized dashboard. Our project combines the power of Google Cloud Platform, artificial intelligence using Gemini, and real time analytics. The goal is simple to reduce manual monitoring and help organizers to respond to cyber threats faster and smarter. I'm Faiha, and I'm for the first part of the presentation. I'll explain the problem statement, objectives, solutions, and system architecture of CyberShield. No. Today, organizations generate massive amounts of system logs every minute. These logs contain important security information such as login attempts, IP requests, access activity, and network events. The problem is that traditional monitoring system cannot keep up with huge volume of data. As a result, many threats remain unnoticed until it is too late. One major threat is brute force attacks, where attackers continuously guess passwords until they gain access. Another issue is IP flooding or DDoS attacks, where systems are overloaded with massive traffic to crash services or hide deeper attacks. We also have unusual access patterns like from unexpected locations or odd timings, which are difficult to identify using static roles. And finally, most organizations lack a centralized monitoring system. Their tools are fragmented, making security analysis slow and inefficient. So, overall, the challenge is clear. Threats are moving faster than traditional detection systems. Talk about objectives of CyberShield. To address these problems, CyberShield focuses on four main objectives. The first objective is automated threat detection. Instead of manually checking logs, the system automatically scans uploaded JSON logs and identifies suspicious activities instantly. The second objective is AI-based threat analysis. We use Google's Gemini AI model to generate intelligent summaries, risk assessment, and even security recommendations. This makes the analysis more understandable and actionable. The third objective is real time processing. Using scalable Google Cloud infrastructure, CyberShield processes logs immediately after upload, reducing detection delay. And finally, centralized visualization. All dictated threads are displayed in a unified Looker Studio dashboard where users can monitor attacks, filter by severity, and observe attack trends in real time. So essentially, CyberShield transforms raw log data into meaningful security intelligence. Talk about proposed solution. Our proposed solution is a fully cloud native cybersecurity analytics platform built entirely on Google Cloud Platform. The workflow begins when a user uploads JSON system logs into the platform. Once uploaded, CyberShield automatically scans the logs and detects suspicious activities such as brute force attacks, IP flooding, or unusual access behavior. After detection, Gemini generates detailed threat summaries, and risk analysis in natural language. The processed results are then stored in BigQuery, which act as the centralized analytics database. Finally, all information is visualized through Looker Studio dashboards, allowing security teams to monitor incidents in real time. So, instead of using multiple connected tools, CyberShield combines threat detection, AI analysis, cloud storage, and visualization into one intelligent security platform architecture. Now let's look at the architecture behind CyberShield. Our system follows a fully event-driven cloud architecture. First, the user uploads logs through the React frontend. These logs are stored in Google Cloud Storage. The upload event automatically triggers the event arc, which invokes a Cloud Run service containing a Flask backend API. Instead, inside the backend, three major operations happen. threat detection, AI analysis using Gemini, and storage into BigQuery. Once the data is stored, the Looker Studio dashboard updates automatically and displays the latest threat information in real time. This architecture gives Cybershield several advantages such as scalability, automation, low latency, and real-time processing. Because everything is cloud based and event driven, the system can efficiently handle large volumes of security logs without manual intervention. So, that covers the problem statement, objective, solution, and architecture of CyberShield. Now, I'll hand over the presentation to my teammates who will explain the technology stack, threat analysis, and dashboard implementation.
To understand how cyberspace operates, we must first look at the foundation we have built. Our technology stack wasn't just chosen for its popularity, but for its ability to handle high velocity security data. Front-end development. We utilize React JS to combine with Python to ensure our user interface is not just fast, but highly responsive under load. To match the intensity of a security environment, we develop custom CSS with a cyber-themed aesthetic, ensuring the SOC experience feels professional and focused. Backend architecture. The brain of our operation is a Python Flask REST API, which is a containerized approach deploying on Google Cloud Run, which allows our backend to be likely and automatically scalable based on the volume of loads being processed. The GCP ecosystem. Our infrastructure is entirely cloud native. We rely on Google Cloud Storage for initial load ingestion, BigQuery for high performance data warehousing, and event track to maintain an asynchronous event driven workflow. The AI layer. Unlike traditional systems, our AI engine is powered by Vertex AI Gemini. This allows us to move beyond simple if-then logic into the realm of intelligent threat summarization and dynamic risk scoring. Now let's look at how an cyber shield actually identifies and interprets danger. Automated detection. We focus on high impact threats like brute force attacks where we identify repeated logging fail attempts from both single and distributed IP addresses. We also monitor for IP flooding, flagging abnormal request volumes that suggest a DDoS attack in its early stages. Behavior anomalies. The system looks for unusual access patterns, including geographic anomalies such as user logging from two different continents within minutes, as well as off-hours logging and signals of privilege escalation. The Gemini advantage. This is where the AI takes over. Gemini provides natural language summaries, turning a cryptic log entry into a clear explanation of what happened. Prioritization and remediation. The AI performs a severity risk assessment, scoring incidents so that security teams know which fire to put out first. It doesn't just stop at detection. It provides actionable security recommendation, giving admins a step-by-step recommendation guide for every threat detection. Building a cutting-edge technology platform comes with significant engineering hurdles. Transparency about these challenges is what helps us to build a more resilient system. Overcoming trigger failure. One of our earliest obstacles was 7 track trigger failures. We experienced intermittent delivery issues, which forced us to engineer robust retry logic and comprehensive error handling to ensure no logs are went unalert. Data integrity. As log formats evolve, we hit BigQuery schema mismatches. We solve this by implementing schema versioning, ensuring that our data warehouse remains flexible enough to handle different load structures without crashing. Working with large-scale AI meant navigating genuine AI quota limits. We optimized our performance by implementing request tracing and exponential backup strategy to maximize our throughput, ensuring to prevent the system from wasting resources on the same data. We added importantly checks, ensuring that duplicated logs do not lead to redundant AI enhancements. Looking forward, we have a clear roadmap for cyberspace evolution. We are moving towards real-time streaming using a top-based ingestion model to reach near zero latency. So as we discussed, we plan to integrate automated IP blocking, allowing cyber thieves to talk directly to firewall tools for instant containment. Advanced model. We will implement ML with anomaly detection models trained specifically on an organized unique historical log patterns. Thank
So to conclude, Cybershield is not just a it is a fully functional production-ready cybersecurity platform built on Google Cloud Platform. We identified a real-world problem. Organizations are constantly under cyber attack, but don't have a simple, intelligent system to detect and respond to threats in real time, and we solved it. So with just one JSON upload, our system automatically does four things. It saves the file to the cloud storage, detects all the threats and store them in BigQuery with a strict required schema. Then it's an AI-powered executive summary using Vertex AI and Gemini and visualizes everything on Looker Studio dashboard. We built the entire front end using React.js with live animation, the backend using Python Flask and connected everything to four real Google Cloud services that are running live right now. Our project also aligns with the United Nations Sustainable Development Goals, SDG 9, which is Industry, Innovation and Infrastructure, and SDG 16, which is Peace and Justice and Strong Institutions. CyberShield proves that with the right cloud tools, even thank you. I hope you got an idea about what is our trust about, and then all the overview of that, what is it doing. So I'll show the live demo of our web app. So basically, this is our dashboard. And then here we can upload the log files in .json format. And then when we upload the log files, it will analyze the log and will scan it. And then it has now identified total number of threads. So it has identified total of 12 threads. Then three of them in that is critical. Then six is high severity and three is of medium severity. And then when we hover over the critical, uh, yeah, so when we hover over high, we can see the thread type, then the user, and then the IP address, and how many attempts that they have made. And then when we go to medium, it is unusual access. Basically, if we are accessing a website or something at 3 a.m., which is unusual, so it is detected. So this is our like this is what is happening in our project. Now let's look at the four components that we have implemented by using Google Cloud Services. Now let's see what are the Google Cloud services that we have used. So firstly, we have used the Vertex AI, which it is integrated with Gemini. So as you can see in this dashboard, uh, we send a thread data so to Gemini, and it is returning a professional security report based on that. So we have did this with enabling the API keys of Gemini, and then we have put it in the code, and then we have it connected Vertex AI and this our web app. So it is all done with the key, and um, in this code snippet, it is like explaining the core function of generate AI summary. So where we have given our API key and everything, and then we have where we have combined it. And then when we look onto The next thing is cloud storage. So cloud storage, if we click on the bucket, and then our whichever logs that we are entering in our dashboard, it is getting loaded here in this bucket. So when we click the cyber logs bucket, and then when we click on the log, it is showing all of the files that we have uploaded while the detection of the threat that is there inside the log. So like this, we have implemented our cloud storage. Then next is BigQuery. So in BigQuery, all the detected threats. This is where we have applied our BigQuery, and then when we click on the detected threats, we can in this preview we can see the databases that have stored, like for example, admin and their IP and the type of threat that they are like enforcing, and then the severity of that is stored in this. So we have like connected the BigQuery with the cloud, with the code, that the front backend that we have done. And this is how we have implemented the Looker Studio. We have also used Looker Studio as our third Google Cloud Services, where it is showing this pie chart of what percentage of threats, and then again a bar chart which is recording the count of the high, critical, and medium. And the next, uh, yeah, that's it.